So team, welcome to ISTQB Foundation level certification training day 3. So we have completed one demo orientation session followed by demo day 1 and day 2. Is there anybody who's just joining today? Is the first class today? Even if anybody is there, I would strongly recommend to go watch the orientation to get the complete picture on the examination structure. Yeah, Shiva, so I would strongly recommend to go and watch the orientation video. I will be anyway quickly recapping on day 1 and day 2 today, but orientation I would encourage you to go watch it. That will give you a complete picture of the exam, how many questions, syllabus, structure, what are the different levels, and which part of the geography that you are going to attend the exam. You can check the local website to check the dates in the near future where you can appear for the exam, and what is this foundation level is all about, and what are the other levels that are there. So you will get a complete picture of the orientation of ISTQB, what is all about. Okay, it's basically a non-profit organization based out of Belgium, and they are responsible for conducting this ISTQB certification for worldwide, and in every country they have a website. So the main website is ISTQB .org is a main website, but from that you can go to your local websites based on the need. For example, it's in the worldwide. You can find your local member board, and you can find out your who is exam provider, and then what are the different certifications that are there, what are the different exam questions. You can watch through the orientation video. You will get the complete picture of it. Okay. So pretty much I kind of walk you through all these options that are there in the website, and yeah, so that was pretty much on that. Then, so to give you a complete perspective, so we will be going through 6 different chapters in this course, and every chapter would take about 4 sessions. So in a way 24 to 25 sessions for the understanding all the concepts. At the end of every chapter, we will conduct a test to go through the knowledge of that particular chapter, and at the end also we'll do a grand tests about 3, and then I'll be handling there's a question bank of 500 questions with answers. If you can go through all that, I'm damn sure you can get through this exam. So that's the kind of people who attended, who have completed the exam as a feedback from them. So I hope the same confidence, if you take it seriously, you can easily go through it. Alright, so with that, we got into the chapter 1 actually in day 1 and day 2. We started with understanding why testing is necessary. We just given a couple of examples, why generally software will failure, what are the reasons for the software failure, and then we also gone through the definitions of, like, people use different keywords for different things, like, different names for different things. People say bug, fault, defect, risk, failure, error. Somebody say I found an error. Somebody say I found a bug. Somebody say I found a defect. So what are those differences? That you will get it through day 1 video. But either of the way, this is the flow. Somebody does a mistake either in the requirements or design or code, and that will result in a defect. What is a defect? A flaw in a component or a system which the system will fail to require the function. It's basically deviating from customer expectations, and that will result in a failure. What is a failure? Deviation of the component or system from its expected delivery, service, or result. So somebody does a mistake, will result in a defect, will make the system failure. And when generally defects will arise, it can be, like, since I've already explained it in detail day 1 and day 2, I'm just rushing through it. You need to watch those day 1 and day 2 to get very detailed explanation. Typically, if everything goes, requirements correct, design correct, coding is correct, project will be delivered without any issues. But in general, the percentage of that success is very rare. The chances are that requirements may be correct, design may be correct, but developers may do mistake while coding the system, and that will result in a lot of bugs in the system, and that's where we as a quality control team, testing team, are responsible for finding all those defects. So the situation, the second flow I'm explaining is there is a mistake done by developers. Because of that, project has defects and failures in the system. It can also happen early that the design itself is wrong. So requirements are captured correctly, but design went wrong. If the design is wrong, obviously developers will do it according to that. Testers also will test according to that, and it will have a result of failure in the system. Things can go wrong in the very first place, requirements itself. So if the requirements are captured incorrect, design will be incorrect, coding will be incorrect, testing and the project will go to live incorrectly. So these are some of the situations when generally defects will arise. And we also looked at the cost of the defects. I gave a good example of dollar by dollar how it will change when you move from requirements to design to coding to testing to UAT to production. So that you will get it from day 2 video. So but if you look at this picture, if you can eliminate all the issues during the requirements itself, all the errors that people have done, mistakes, if you can eliminate them in the requirements itself, cost will be very, very less. But as somebody did a mistake in requirement, if it is caught in design, the cost would have been exponentially increased. If it would have been found in coding time, it will be much more higher. If it is found in during the testing phase, it will be much, much higher. That is still better, and that's why people encourage the testing team in every organization, testing as a separate discipline in every organization, because we eliminate all the issues before it goes to live. But once things go to live, it will be much more worst. It can result in lots of rework, customer reputation, and there are such situations where companies have simply closed because of their product failures. So we don't want to take the chance. That's why we wanted to cut the cost at the testing phase itself. People are ready to spend money on the testing because once it goes live, the things will be worst. So this particular graph will explain how the cost will increase as it moves from requirements to the live. Now, how can we ensure, there's one another picture that I've explained, how can we make the software under control? So as somebody defined, a quality project is something, it's not just about free of bugs. It's not just free of bugs. I can go on developing and testing the product for a long time, and in fact I'm actually crossing the timelines for the required for the project, crossing the budget estimated for the project, but I'm eliminating all the errors, all the defects. It's not a very I would say best product. A best product or a good product is something that has to take care of all these three. It has to take care of the time, it has to take care of money, and it has to take care of all the features that what you have promised. If you give all the features beyond the timeline, obviously no use. Like, money will increase, time will increase. It may not be really useful for the customer. For example, one of the customer has given you this project based on the upcoming season, maybe holiday season. And if you are giving the product after the holiday season, then there is no point in giving it to him. So a quality software is something that has to take care of all the features what customer is expecting within the money that you have quoted him, how much it would cost with your estimations, and what are the timelines that you have promised. So it has to meet all those three. Otherwise, it's not a good quality software. And testing is not just about functional testing. Most of the people stick to of course, they start with the functional testing, ensuring that the requirements of the basic requirements of the application. For example, if I'm developing an e-commerce application, the purpose of it is to do an online sales. So as long as if people are able to search the products, make the payments and get the delivery. That's a functionality. But there can be so many other things that system has to take care which are non-functional, like it's security, how secure your system is, because people are going to give you their personal information, people are going to give you their credit card, debit card information, people are going to give you their bank details, and what payment gateway system that you are using, how secure it is. Security plays a major role. And how about the load and performance? How many users can simultaneously work on this system? What is the response time of your application? So all that basically in under non-functional, so many things will come. So testing only functionality is not enough. We have to take care of non-functionality like load of the system, performance of the system, security. I don't like writing security as non-functional because in today's world security is a default. You cannot compromise on that. So I would always prefer to put it under functional, because previously security testing was a specialized testing, but I don't consider any time it's specialized because it has to be a default. Without any system secure, you cannot actually release the system because any issue related to security will create a lot of problems. So I don't want to consider it anymore it as special. Security, then you have to take care of localization, globalization. For example, if you are planning to release your product into different countries, different states within the country, then comes your localization, globalization. And very important is accessibility. Accessibility is like nowadays, it is mandatory in most of the countries that you have to develop your system which can be used by all kinds of people. Low vision people, blind people, color blind people, all kinds of people should use it. Oh yeah, so Ariel says, but based on ISTQB certification, is the group security under the non-functionality kind of test. It is categorized as non-functional testing, but with the kind of, so if you look at the latest trend, that's where I'm coming from. Because every application that you develop is a security prone application, security risk application. So that's why when I ask my team to do the testing, if somebody says, come back and say, I'm done with my functional testing, the first question I'm going to ask them is, did you cover all the security test cases? If they say, it's a non-functional, I would probably not very inclined to them. Then I'll say, no, go cover those also, because that's a basic. So that's where I'm coming from. But yes, I think we have to stick to what ISTQB expects also, right? You're reminding me that point. So from that perspective, yes, it's considered as non-functional testing. Accessibility testing is also very important. All kinds of people should be able to use. That's why if you see in most of the devices, most of the softwares, the new feature like voice enable feature is available. So which will read out the content on the website or read out the content of the application. This is kind of mandatory. So there are a lot of things we can like this. There are so many things that we'll have to take care in non-functional. So that's what this point is explaining. So it's both functional as well as non-functional testing. Very important, you have to understand, we are not going to remove defects. Testing is not to remove the defects nor to enhance the quality. All your job is identifying the defects and reporting them so that you are helping the development team to improve in fixing them and improving the quality of the software. And it is also very, so you can go through these points and go through day 2 video, which I have already covered. The biggest question that people will have in mind is when to stop testing. When can we say, testing is good enough? Ideally, it's very, very difficult in the sense like, we cannot test everything even if you wanted to really test. Even, let's say in a project, you have written 1,000 test cases, but what is a guarantee that that 1,000 is complete? right? So of course that's where the tester's capability comes. What are the different edge cases that he is thinking? What are the different boundary values that he is covering? What are the different techniques that he is using to cover all kind of combinations? All that will come into picture, but still the number of test cases are more. So what we would recommend is to do prioritization. Like, out of 1,000 test cases, prioritize them, which are most important, which are medium important, which are less important, and then you should go about testing the high priority first, then to medium, then to low. And if you still have some time, go and do the priority test cases second cycle also. So generally it's always recommended to go at least 2 cycles of testing. What does that mean? If I have 1,000 test cases, if you can execute all these 2 times, that's well and good, but nobody generally will have that much time, especially in today's agile world. You will have that much time. So what we encourage is, out of 1,000, let's say 200 are priority 1 and 400 P2, priority 2, another 400 P3, some simple test cases. So what I would say, at least you test all these once, one cycle. In second cycle, at least test the first 200 minimum. If you have time, some of them P2. And don't do this second cycle by the same person who has done it. If tester 1 has done this, give it to tester 2, because giving it to the same tester is not going to help. So that's what generally we do, and after that you will obviously realize there are not you cannot say there are no errors, because we never know. Still the defects can lie in any of the corner, but in spite of you doing your best job, you realize there are no more defects coming up and you are very confident that the system is working fine, then we'll sign off. So, but that's how we have to decide. But you cannot really test everything even if you wanted to do it, because nobody will have that much time. Okay, this is what pretty much I covered in day 2. So any questions, people who have attended my day 1 and day 2, so that I want to take those questions first and then we'll move ahead. In fact, anybody can ask. It's not that, but I would expect at least from the people who attended day 1 and day 2, if you have started reading or if you have gone through those videos, you would have some questions. If not, also I'm good, I can move ahead, but I just want to pause it for a minute to see if anybody has any questions. This material is prepared in such a way that line by line is very important. So I will be sharing all these documents to you post today's session. People who have completed the registrations and everything. So you all will get an email with the Google Drive access, wherein all these notes are there. So start preparing, go through line by line, make a questions. You can ask me in the next session. I'll answer them first and then we'll move ahead. So that's how we'll go. Clear? All right, so let's move ahead. So this is where technically we are starting day 3. So what basically testing is and what it does. People try to confuse between the testing and debugging. Okay, there are 2 different terminologies. Rather, there are 2 different activities. Debugging is a process that developers will use or apply to identify the cause of bugs or defects in the code. For example, you test something and then you report a defect saying certain feature is not working. Maybe I'm not able to search. Typically, if I take an e-shopping application, you reported something saying I'm not able to search through a particular category. Let's say there is a category, and when I select this category and click on search, I'm not seeing any items. That's what you reported. But you have seen through other source, maybe in the back end, or maybe in your customer list, that category items are there. It's not that they are not there. It's there, but they're not getting displayed on the application is the issue that you reported. And that's a very important category. So you reported something like severity 2. Well, again, I have not talked about what is this 1, 2. We'll be talking it through soon, but you report as high issue, very important critical issue. Now when you report this issue, that's where ideally your job ends. Basically, that's what we told in one of the previous point, right? Testers are not going to fix those issues, but rather they will help in improving the quality. Okay, there's one question in the chat. Let me take that first. Is it possible for the component testing phase to consider debugging as a tool for testing code in case the testing team have access to it? Let me just finish the debugging definition, then probably you yourself will be able to answer it. Okay, so as a tester, I was executing this particular test case. Then I realized this category list is not getting displayed, so I reported this issue. Ideally, that's my primary job. Reporting the issue is my primary job. Of course, while reporting, you need to ensure you are giving all the required information in which feature, which screen, what category you tried, and what error you're getting. If possible, you need to give a screenshot, the error message, if at all it is giving any error, everything you have to give it. Then only you are actually helping the developers. Otherwise, you're actually confusing the developers to spend more time in reproducing it. So you try to reproduce and then you give all the information. Now developer, what he's trying to do is he will try to debug the code that he has. He has that feature. Let's say this feature is where categories code. Maybe if it is a C#, we will have some CS file. If it is a Java, you will have some Java class files. He'll go through, he will insert a breakpoint at a particular line where he has a doubt, and then he will run this program into debug mode so that it will come and pass here. Then he will go line by line, and then he will enter the category what you are actually entering, and after that he click on the search button, and then he will see exactly what is happening in his debug mode. The debug mode will tell him if there is any error coming or actual exception coming or what. So that's what is actually debugging. So debugging is basically identifying the logical errors in the system. So if you wanted to define, basically it's identify logical errors in the system. What does that? It's not, program can have 3 types of errors, right? So it can have syntax errors. So this is not a syntax error. It is not it's not giving any exception also. Okay, so it's not a runtime error also. It's not a runtime error also. But maybe when he is actually querying from the database, his query may be wrong, and that's why it's not getting anything. So that's where the problem. So he will go line by line to the point where the problem is, and then he will understand the problem. He will fix that problem in the debug mode itself, and then see it's working. Okay, after that he realized it's working, then he'll stop the debugging, make the actual fix, and then submit it to you saying, hey, now it's ready for the fix, can you please verify it? And when you verify it, it works fine. So debugging is basically debugging is basically it's a process for the developers to go through and identify the cause of the bugs, what is the root cause of the bugs or defects in the code, and then undertake corrections. So that's what it is all about. When you report the defects, so they will start this process of debugging. So is it clear now? If you read this question, I really like, is it possible for the component testing phase to consider debugging as a tool for the testing code? I would say not component testing. Yeah, actually, if you're using the other term, that's right. Unit testing or component testing, correct. So during their unit testing, ideally, this is what I've been telling, right? So developers are not only responsible for writing the code, they have to write the code, they have to do code reviews themselves or peer level, like what one developer has done, give it to other developer, what other developer has done, give it to other developer. They are also responsible for unit testing or component testing, as Ariel is mentioning. So this, yes, during the unit testing or component testing, you will go line by line. You will ensure this individual unit is working fine. You will try different combinations of inputs and see it's working fine. And if you, if the developer sees anything is not working abnormally, then he will also debug to see what is the problem. A lot of times during their unit testing, obviously they'll be using debugging for sure. Whereas a testing, on the other hand, it's a systematic exploration of a component or a system. Probably the developer will go line by line and see where the problem, but the testing is something, it requires a special skill actually. It's you have to think through different, you have to get into the shoes of a customer, think through what different customers can try on my system, and all that you will try it in a very systematic way. If he goes and search a particular X category, what will happen? If you search with a Y category, what should happen? In case of X category with Y combination, what should happen? You will go everything in a very systematic way. And those systematic things you write in the form of test cases. And you go about executing each of those test cases. Then definitely there will be some situations where your developer could not test everything, because you cannot expect him to test everything because he is primarily responsible for writing the code, but of course do some unit testing. And that's where we find all the major issues. And so your job is a systematic exploration of a component or a system with the main aim of finding and reporting the defects. So that is your primary job. Testing does, however, ensures the changes and corrections. You're also going to do one more thing, which is I can put this entire one line in a technical term called regression testing. We call it as regression testing. So when you find some defects, you give it to developers. Developer will debug it, identify the root cause, and then take the corrective action. But sometimes when they take the corrective action, it will actually fix the issue. Sometimes it will actually make the system worse. They fix the issue where they are actually trying to do, but it will actually introduce so many other issues in other components, other features. So that's where the challenge lies for the testers, to test all those impacted areas. For example, you reported this issue saying categories list is not found. So he debugged that category class file, he found the issue, but without really bothering about in all other areas where it will have an impact. Maybe he does not have a visibility, he did a quick fix. That actually quickly fixed this, but it introduced so many other problems in other components. So when it comes to you for the testing, when you're actually doing the testing, you realized this is working fine, but it failed feature 2, feature 3, feature 4, so many other features failed. And it's a very common thing that happens. So that's where another challenge for the testers lies, and we call it as a regression testing, where you go and do all your impacted areas also tested before you say we are good from the quality perspective. So any questions on testing and debugging? Is it clear what is testing, what is debugging? Because this generally, especially people who are new to the QA world, they'll get confused actually. If you're already working, I'm sure you will know the difference, but it's my job to provide the basic definition for the examination point of view. Then comes another question. You might have heard about static testing and dynamic testing. Then what are these two? Right? So static testing is a term used for testing where code is not exercised. Just remember this line. You're not actually really testing the code. Okay, if you're not really testing the code, then what are we testing? It could be something like, suppose if I give you one user story. Today's world is all agile, right? So if I give you a user story, or if I give you one requirement, okay, in the classic waterfall model, we call it as requirements. In today's agile world, you call it as user story. Suppose if I give you a requirement, or if I give you a user story, and as a tester, what you're going to do? If I ask you to go through this requirement and see if there are any issues with this. So all you do is review, right? So what you do is basically you do a review of it. And what kind of review you do? You review in such a way that you look for the correctness, first thing, whether it is correctly documented or not, and you look for consistency. Suppose in one paragraph it's explaining about one way, in another paragraph the same thing is explained in a different way, so it's not consistent. For example, in one of the reporting feature, they are saying user will come and enter start date and end date in the form of MMDDYYY format, and you should give the report for all these dates. In other section says customer will come and enter the date format DDMMYYY, and you have to report. So there's no consistency in the date format what customer is going to use. So that's kind of discrepancies you will find out. So correctness, consistency, and you will majorly look for completeness, whether everything is properly explained or not. If any of the feature or requirement is incomplete, you cannot really take that as base for your testing. Now, what are you actually doing is you are doing something called static testing. You're not really testing the code here, but you're actually verifying a document is correct or not. So this is called static testing. Same case if I give you a design document, and if I ask you please go through this design document and see if you have any questions, then what you do is again static testing. So you'll actually review the design with your knowledge, whatever you have. If you have any questions, you'll come back and ask the designer who actually designed the system. So it's basically again a static testing. But after requirement, after design, when the developers actually code it, and when they give you an installable, or when they give you a service, installable or some service, what you're going to do is actually a dynamic test. You will install that software, or you will connect to that web server or web service, and then you test it. That's called dynamic. You're actually testing the code behind it now. So if you're testing the code, it's dynamic testing. But if you're not really involved in testing the code, that's called static testing. So any document verification is called static testing. But dynamic testing is a kind that exercises the program under test with some test data. So we speak of test execution in this context. So what you do, you try different inputs and you see they are working or not. So underneath what is happening, the code what is written by your developer is getting executed. So that is dynamic testing. So any questions in the difference? There is a separate chapter, chapter 3 talks about all these techniques and all these techniques. So don't worry, it's just a definition in chapter 1. But I think chapter 3 we're going to completely look at what are the different static testing techniques are there. Like what is a review, what is an inspection, what is a walkthrough, all that we'll discuss. No. Okay, Ariel is saying basically in the static testing we check the ambiguity on the documentation, and in the dynamic we execute test cases. I would say any document that you review is called static testing. But ideally I have explained when you review what is your aim is this: you look for correctness, you look for consistency, you look for completeness. You're correct. But just to give the definition of static testing, anything like requirement or design, if you review, that process is called static testing. Simple, post the session, if I give you this document, and if you'll come back with me, hey Shankar, there is a correction required, then what you have actually done is a static testing. Right? Any questions in the high-level definition of it? As I'm saying, chapter 3 is completely dedicated for them. The next thing is about testing as a process. We need to have a clear objectives for every test. You cannot just go on randomly testing something. Of course, random testing is also one of the technique, but that's not the only technique that's going to help you. Okay, Swati is asking what is a component. Okay, let me just, since we use that word 2-3 times, let me talk about. So what happens typically is, this is a big project that the team has to develop. So they break the project into different modules. Module 1, Module 2, Module 3. For example, project is e-commerce, online application. But they cannot develop this entire thing as one module. This is basically, let's say, customer module. This is orders module. This is payment module. So they divide the project into modules. These modules may be further divided into sub-modules if required. For example, order, cash on delivery, prime delivery, like maybe within 24 hours, normal delivery with payments, for example. Something like that you divide. So sub-module 1, sub-module 2, sub-module 3. If required, this will further break down into smaller chunks. Those smaller chunks, we call it as units. Unit 1, Unit 2, Unit 3. Unit, or you can call it as component. Now if I try to define what is a unit is the smallest component in the system. I cannot further divide this. It could be just one feature. It could be just one page in my system. Just one, maybe one small feature, like what is the second one? Cash on delivery, prime delivery. For a prime delivery, I wanted to have one page. In that page, I wanted to list out all my services that I wanted to give it to a prime customer. That's the page. Sorry, maybe some rules and regulations I wanted to display for a prime customer. That's a simple page. So this page, one developer can work and he can finish it in one day. Max to max, today's world agile, I would say one day, max 2 days of work. That's it. If it is going beyond this, probably I can further divide it. So that is what is called unit or component. Is it clear, Swati? The smallest component of the system, which can be done by one developer, probably in a one day or max 2 days of time. Then once individual units are developed, then they have to be integrated so that this module will be ready. Then modules have to be integrated so that this will be ready, and this should be integrated so that project will be ready. So that is how we'll go. Okay, so testing as a process, it should go. Like testing team especially requires a clear vision, clear direction. What is it they wanted to test? You cannot just go about doing something randomly. Random testing also finds bugs, but that should be the last testing, not the first testing. So when generally, if you have heard about random testing, also people call it as ad hoc testing. Some people also call it as zigzag testing. Some people also call it as monkey testing. The way monkey jumps from one branch to other, you will jump from one feature to other. That should be your last testing. When actually good thing is, suppose you're done with everything. You started with a unit testing, then integration testing, then system testing, your functional testing, non-functional testing, everything you got executed in a very sequential manner, very systematic manner. You eliminated all the defects. You eliminated in the sense you reported and your developers are fixed. Then you also retested them. But you still have, let's say, another 1 week time or maybe 1 day time. Then it is makes sense to go do some random testing. But random testing is not something that you have to do as a first one. So that's what I'm trying to highlight here. It has to be a very systematic thing. A test should be designed to give a confidence that a function works according to the specification. So you have to design the test in such a way that when a customer is asked, for example, customer told a feature, I want something, payments should happen through a credit card system, for example, just an example. Then you have to design your test in such a way that what are the different options will be there in credit card, what are the different types of credit cards, and what if a card is expired, not expired, credit limit expired, not expired. All that combinations you have to go in sequentially to execute them so that the feature is working as expected. It will be quite different from one design to find as many defects as possible. And then it's of course, the good thing about the testing is that you have to find as many defects as possible, but you have to go in a systematic way. You cannot just jump here and there to find maximum thing. Then you will actually confuse what feature being tested, what feature not being tested. It's a confusion. So you have to go in a very sequential manner. We define the test process to ensure we do not miss any critical steps, and we do these things in the right order. In fact, you have to go test critical features first, followed by medium complex features, followed by less complex features, because there are highly chances critical features will have a lot more issues. Because when the developers are writing the code also, critical features, they will struggle writing the code. And when they're actually struggle writing the code, there are highly chances the mistakes will be in those areas. So I think that's there in my next explanations. We'll see. So, but any questions on this? Any? Just a quick recap. Is everybody clear on what is debugging? What is testing? What is static versus dynamic testing? What are the other elements apart from test execution are included in testing? Other elements is basically this one. So you are going to aim at finding as many defects as possible, but at the same time you have to do it in a very systematic way. Okay, some of the general testing principles. Remember, this is main principle. Testing shows the presence of bugs. By doing the testing, you will tell to the world of your project team, here are the bugs. Component X has a bug, component Y has a bug, module 1 has a bug, module 2 has bugs. Is that what you're going to tell? But remember, you can never say that the software is error-free. You don't know what bugs are still lying in other components. Even with your knowledge, you have written 1,000 test cases. All 1,000 test cases are executed. Still, there might be some cases that you cannot really say this is 100% bug free. I can tell you one simple, even the projects that we are using today in the real world. For example, we are using this GoToMeeting for joining the meeting. I cannot say this is completely bug free. There might be still some problems they will encounter when the situation will arise, when somebody execute that particular scenario, the combination, that issue might come. But it's being released, it's being live, thousands of millions of people are using it. So what is that point that I'm trying to explain is, doing the testing, you can say where are the bugs, but you cannot say it is completely bug free. We'll never know. Still there can be some situations. But you try to eliminate as much as possible within the time that you have. So nobody has ample time to test everything, right? Probably if I give you this product and 1 year time, then you might eliminate everything, but nobody will have that amount of time. Within the time that we wanted to give it to the customer, you have to eliminate all the possible issues. That happens only when you go through, do it in a systematic way, test critical features first, then medium features, then low features. If you're hanging around only on the low features for a long time, and if you're leaving the critical features, then obviously you're not doing the right thing. The main purpose of the testing is to find defects, so therefore test should be defined to find as many defects as possible. Of course, our job is to find as many defects as possible, to do it in a systematic way. So any questions on the first principle? Testing can show only the presence of bugs. It will never tell you it's bug free. What you tested, if you find a defect, you can say here is a defect. But is there any other defect that's lying there? That we don't know unless we test. Exhaustive testing is impossible. This is another point, another basic principle. Even if you want to test all the combinations, you cannot really test. Simple, the same payment gateway system if you take, there are different ways of making the payments through credit card, debit card, net banking, blah, blah, blah. Within each of them, you will have so many combinations. And all together, if you really put it together, it might be 500,000. I don't know, but it's that you cannot really test. Even if you test it, for example, you want to test with a amount balance of between 1,000 and 2,000. You cannot test 1,000, 1,001, 1,000, 2,000, 3,000, 4. You cannot really test. So we use some of those experience-based techniques, black box techniques, to help us. And then we'll say, by testing some samples of data on the boundaries, we'll confirm, I think we're good. Let's go ahead. But you cannot really test everything. A test approach in which all possible data combinations are used. That's what you cannot do. So what you should do is, unless it's very simple, for example, if I give you just a login form with a user password, OK cancel button, and if I ask you, did you test everything, then and there you will miss so many combinations. Just do a quick thing, like, let's see, if I give you the simple form, you have a username, a password, a simple OK, cancel. If I just ask you roughly, what all you tested? If I ask you to give you this for verification and you should tell me whether you're good or not. Just quickly throw some ideas. What all you'll test? Team, are you there? What do you test? Okay, Ariel is saying at least 4 test cases for the functionality. Okay. Anybody got more than 4? Oh, she's saying at least 4. Can you tell me what is the maximum number of cases that you have thought through in your mind? Okay, each of you just tell me what are the maximum number of cases that you thought through, and that number if you can put in the chart, that will help. So probably you need to answer Ariel again because you told at least 4, but what is the maximum number that you are thinking through? Invalid user ID, valid user ID, incorrect password. Okay, just throw me some number, that will help. You can do that maths on your paper and tell me how many you will test. Okay, Jignesh is saying 8. Any other better number? Any other better number? Nagamani is saying 16. Any other better number? Just to tell you what is exhaustive testing and why can't we test everything. Of course, it's person to person different, but still. Any other better number than 16? $16 is a max? Okay, if I try to do, let's see what will happen. I'll simply take this combination, so username, sorry, password. I'll try both of them valid first. I'm a very positive tester. I'll go with a very positive scenario first. Then I'll try valid, invalid. Then I'll try invalid, valid. Then I'll try invalid, invalid. Then I'll try one of them blank. Then I'll try the other one is blank. This can be valid or invalid, doesn't matter. Valid or invalid. I'll go with the blank. Okay. Then I will go with verifying the title of the page. Okay, how many we got it? 3, 3, 6. Okay, I'll try both of them blank. 7. So I got 7. 7 with OK button. 7 with cancel button. Just don't ask me. No, you can actually ask. I'll explain, but at high level. 7 with OK, 7 with cancel. I'll verify the title of the page first. There is no title. That's a bug. I'll verify the alignment of the objects. I'll check first whether the username present, password present, OK button present, cancel button present. OK button should be disabled first, cancel button should be enabled first. Then I'll check the spelling of username, spelling of password, spelling of OK button, spelling of cancel button. In cancel, whether the C is capital or not. In username, U is capital or not. Password, P is capital or not. The alignments of these objects is correct or not. So that alignment, I think I told one of the alignment I'm going to test. Then I have those basic minimize, maximize, close features or not. So I'll test those 3. I'll test all this. Maybe around 30 cases. And like this, where how many controls you have? Only 2 controls. Think of a form with 2 different or 3 different things, with 3 different radio buttons, with 5 different check boxes, just a combination, and a table. You cannot really test all those combinations. So exhaustive testing is impossible. So that's why you have to categorize, and you have to see which is high risk, which is high priority, and you have to test them first. Another very important aspect is early testing. If you can find the defects early in the cycle, that will help. For example, your testing cycle is starting from May 1st to, let's say, June 1st. That's your testing cycle. If I'm the test lead, I will divide this into 4 weeks. And I'll ensure all my critical things are tested in the first week itself. Or I will complete my one cycle by second week, so that I'll find out all my critical issues, hand over it to the development team, they will fix and come back, so that I will have time to regress them, like that. So you have to plan it in such a way that you will find all the issues early in the cycle. If you simply do small things and all of a sudden you find critical issues in the third week or fourth week, it's not going to help. It actually adds a lot of churn to the project, and developers will confuse. They will introduce more bugs rather than fixing them. So early testing is the best. So the earlier the testing is started, the longer the elapsed time. Testers do not have to wait until the software. And one more important point, you don't need to really wait for the software is really available to test. What you can actually do, you can start testing it from requirements itself. You can eliminate all the issues in requirements. You can eliminate the issues in design. That's why a lot of companies are coming up with a different techniques. Like we did it in my previous organization was, why can't the testers to wait until the testing phase comes? Why can't we engage the testers with the developer in the coding phase itself, so that when the developer writes a code, if this person is a technical enough, he can review the code itself. It cannot be possible in every organization, but if the person can review the code and eliminate the problems then and there, or during the development phase itself, if he can pair developers with tester, and if they can come first, he will write the test cases and give it to developer will write the code according to that, then the tester will test it. So there will be a lot of things will be eliminated before it comes to the testing. So there are different companies are trying different ways to eliminate them, right? And the clustering for the defect is like, how system complexity is, how the code is volatile, who has written the code, is it an experienced developer or inexperienced developer, how many changes we did it after coding. Change is a very constant in the world. Like, developers have completed a coding and then customer may come back and ask for a change. Then you redo it. So change is like a constant. And if the development team is not very experienced, right? So there will be a lot of issues will come. So that's why early testing is very important. And these all things will add to the complexity of the defects. More you'll find more defects if system is complex, code is not very volatile. I would say there are a lot of changes came into the requirements of the project. Development team is not very experienced. Then you will find lots of issues. And there is one principle, it's called Pareto principle. 80% of the defects will happen actually in 20% of the code or 20% of the module. Like just now I have explained, a project is divided into many modules, blah blah blah. Not every module will have issues, but there will be some complex modules where your developers have struggled a lot in coding it. We need to test those things first, because if he struggled, obviously there might be some issues. And this is the Pareto principle generally that says is 80% of the problems lie in the 20% of the code. So if we can test that 20% first, We don't know exactly where, but if you can plan it well, if you can strategize well, that's where the test plan, test strategy comes into picture. So we'll see how to write test plan, how to write test strategy. Then you'll eliminate the issues early in the cycle so that you will have an ample time for re-verification, regression, etc. So any questions in the principles? Probably there are a couple of more principles. 3 more principles. We'll talk them tomorrow. And then I'll do a recap of all the 6 principles. And then we'll go into the other aspects of it. So as we are overshooting the time, I would pause it here. We'll repeat these total 6 principles tomorrow. Any questions, team? Is all good? So be interactive on the sessions, put the questions in the chat during the course so we can take them up. Let's make it as an interactive. Okay, so Ariel is asking, can you go back to the definitions of error, defect, etc.? Sure. What I was saying is error, any human mistake, a human action that will produce an incorrect result. Somebody does a mistake while writing the code or while writing a documentation of the requirement or while doing the design. There is a mistake. That is actually, but generally people also call it as a programming errors, only errors. Okay, but it's basically you can call any mistake that's done by a human is like an error. That will result in a defect. What is a defect? A flaw in the component or a system. There is some problem in the software. Since he did a mistake, that will be initiated, and that will actually result in failure of the system. Some feature doesn't work, a report doesn't come, so that is called failure of the feature. All right, cool. So go with this for today. See you tomorrow. We'll continue with the principles, testing principles. Hopefully we'll be able to, may not be tomorrow, but day after tomorrow we'll be able to complete the first chapter. And then we'll have test, a quiz. Okay, so do start reading it. I'll ensure this Google Drive will be available to you all guys today. Tomorrow there is a class, yes. All right, so have a good evening, good morning, good night, wherever you're from. See you tomorrow.